Okay, this lesson is going to seem like a big departure from what we've been doing, but it's necessary to build to where we're going. So first of all, probability is, and I'm just going to put it very simply, what we want divided by what we could get. Now that is not a good mathematical definition, but I'm going to use that phrase as we go. What we could get. Okay, now technically it's going to be what we want, like the number of times we could get what we want divided by the number of things that we could get. Okay, so I will clarify that as we go. But let's talk about a sample space, and this is the list of all possible outcomes. Okay, so when rolling a six-sided die, what is the probability of rolling a 5? Okay, so we're going to start with a really basic example, but I do want to talk about the sample space for just a moment because it's going to come in handy when we get to some more complicated types of problems. So if we were to roll a six-sided die, first of all, let's just kind of list the sample space. So here's our sample space, and this is really common sense on a problem as basic as this. But sometimes it's kind of handy to write it. So I'm going to put brackets just because it's a big set of numbers, so not a big set. 1, 2, 3, 4, 5, 6. So this is everything I could get. So if I'm going to go back to my original definition, which is not too technical, but yeah, whatever, it works. What we want divided by what we could get, well, I could get any of these numbers, and there are 6 of them. So what's the probability of rolling a 5? Well, it's something out of 6. And you know the answer at this point. You're like, 1 out of 5. And I hear you. I'm just building to some of the more complicated ones that still aren't too complicated. Rather straightforward lesson. A probability of rolling a 5, well, there's one number that's a 5 out of 6, so 1 out of 6. And I don't know if you saw the little subtitle up here, but we're going to write each probability as a fraction and as a percent on these notes. So on each of these, I'm going to write 1/6 as a percent. And in order to do that in a more efficient way than I have done so far, instead of doing the cross-multiplying thing, I'm like 1 over 6 equals x over 100, I'm just going to do 1 over 6 and multiply by 100, which really just moves my decimal place over. And I have 16.6 repeating percent. I'm going to write it like this. It's 1/6 or 16 point, I'm going to round that off, 7%. It's a little bit of, this one's approximated a little bit. Okay, probability of rolling an even number. Now at this point, the sample space comes in a little more handy because I'm like, oh, how many even numbers do I have? So I can look at it and say, oh, well, I have 1, 2, 3 even numbers. So in this particular case, 2, 4, 6. And you can still do that in your head. But again, if I would have asked something ridiculously complicated, then we would need a list so we can kind of go through it. So an even number, well, there are 3 even numbers out of 6. And so that's equal to a half. I'm cool with either one of those, but you know how to reduce a fraction, right? And then I'm going to go ahead and write down what it is, but just to refresh your memory, just because I don't know why I'm doing this. 1/2 is 0.5. We'd multiply by 100 and we'd get 50. I'm just throwing that out there. There's your process. Okay, and now the sample space really comes in handy because it's easy for us to lose track of what we've counted and what we haven't counted. So my sample space right here, 1, 2, 3, 4, 5, 6. I want an odd number or a 6. And so an odd number, so like 1, 3, 5. Or it needs to be a 6. And so there you go. There's your 6. And so I just underlined 4 different numbers. And so I have 4 out of 6, and 4 out of 6 is 2/3 if you reduce it. And I'm also going to say it's either this or if we represent it as a percent, 2/3, and then we'll multiply that by 100, and I have 7%. So 66.7%. So there it is, pretty straightforward. We are going to go to the next one. So I'm going to I need to make a correction on the notes. When rolling an odd number, I didn't mean to say that. When rolling when I typed it, I typed what was going through my head and it wasn't right. When rolling a 10-sided die, What's the probability of rolling a 6, an even number, a prime number, all that stuff. So now the sample space is really going to come in handy. And we're going to have a 10-sided die, and we're going to assume that it's numbered 1 through 10. And actually, I do have a 10-sided die right here. Mine is actually numbered 0 through 9, but we'll pretend like that's a 10 instead of a 0, okay? And I'm about to roll a 7. Ah, dang it. Okay, here's our sample space on this one. And it is going to be 1, 2, 3. And I know you're like, I can count to 10. Hey, I hear you. I can too. But let's look at this one. A number divisible by 2 or by 3. It's going to help to have the list so we can identify things and mark them as we go. So even though counting to 10 is a very basic thing, the sample space is there. So we we'll be able to identify what we need to identify. So what's the probability of rolling a 6? Okay, well, this is pretty straightforward. I will point to the obvious. We have one number that's a 6 out of 10. So what we want a 6. There's 1 6 divided by what we could get. We have 10 numbers. We want one number when we have 10 numbers, so 1 out of 10. That's why I worded it the way I worded it. So 1 out of 10, we could also say that's 10%. Okay, an even number. How many even numbers do we have? Well, 2, 4, 6, 8, 10. There are 5 of them. So 5 out of 10, and that's a half. And we could say it's a half. We also could say it's 50%. Okay, now we get to things like prime numbers. Oh my goodness, what's a prime number? Okay, number where nothing goes into it except 1 and itself. And so we kind of have to go back to elementary school for just a second. This will come right back to you if you haven't used it in a while. 1 is neither prime nor composite. 2 is prime, so here we go. There's one of them. That's prime. 3 is prime. 5 is prime. 7's prime. Because like that's 2 times 2, that's 2 times 3, that's 2 times 4, that's 3 times 3, that's 2 times 5. But there's no other way to write these with multiplication other than 1 times 2 or 1 times 3. So there are 4 prime numbers within the first 10 integers. So, well, from 1 to 10. So prime number, there are 4 out of 10. That's really 2 out of 5. We could also say that is 40%. Just in case you want to see it one more time, here we go. 4 out of 10, we're going to multiply by 100. There's your 40% right there. Saves you some time. All right, now we get to something ridiculous like this. A number divisible by 2 or divisible by 3. What I recommend we do, actually, I'm going to circle them this time instead of getting rid of the underlines that I had. So anything that I circle is going to be what I count for this one. So a number divisible by 2, let's count those. So 2 is divisible by 2, 4, 6, 8, 10. That really is a fancy way of saying, hey, talk about even numbers. So even numbers or numbers that are divisible by 3. So like 3, 6, we're not going to count it twice, but it does apply to both conditions, and 9. And I just need to see how many numbers I circled. So this is where the sample space comes in really handy, because you could look at it and say, oh, well, you know, I need to identify what I'm actually doing. And we just did. So 1, 2, 3, 4, 5, 6, 7 numbers were circled out of 10. And that is equal to, well, it's equal to 7/10. It doesn't reduce. I don't know why I put the equal. However, if we put it as a percent, that is 70%. So 70% of the time when you roll this die, you will roll a number that is divisible by 2 or 3, and I'm about to roll a 6. Dang it. We'll get this right here in a minute. All right, a number divisible by 1. All right, well, let's think really hard about this one. 1 goes into 1, 1 goes into 2, 2 times, 1 goes into 3, 3 times, 1 goes into 4, 4 times, 1 goes into 5. So every one of these numbers is divisible by 1. So this is one of those conditions where we would say, well, there are 10 numbers out of 10 numbers that are divisible by 1. So this is really 10 over 10, which is 1. Now, I know we're used to seeing a fraction over here, but basically it's 100% of the time. So 1 or 100%. So if I said, I'm going to roll a number that's divisible by 1, yes, I did. There's the 6 I wanted earlier. I want to roll another number divisible by 1. Yes, there's the 7 I wanted earlier. I'm going to roll a number divisible by 1. No matter how many times I do this, I'm going to get a number divisible by 1 because everything on here is divisible by 1. Let's pretend like that's a 10. Even though 0 over 1 is still a thing. So there you go. That's the basic probability. We're going to go straight to the back page And there's just a few more to do, and we're not going to list the sample space on this one because it's kind of up there for us. So you have a spinner that looks like this. So let's suppose there's just a little arm on here with an arrow, and you'd spin it around. It's like Wheel of Fortune, only with numbers. And you're not actually going to get any money. And there's not a bankrupt thing, and there's no Pat Sajak or Vanna White. Anyway, so it's not like Wheel of Fortune at all. But here's our sample space, and I'm not going to list it because it's there. 6, 7, 8, 9, 10, 20, 30, 35, 38, 40, 45, 50. And, you know, I don't know what this would represent. Maybe it's something where somebody is gambling or something like that. I don't know, which I don't recommend. Anyway, what's the probability of spinning and getting an even number? So I'm just going to go through here and find my even numbers. Well, before I do, actually, let's go back to our not well-worded definition. It's what we won't divided by what we could get. I want to know what I could get. Well, I could get any of these, but let's count what I could get. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 possible outcomes. And then I want to get an even number. And so that would be 1, 2, 3, 4, 5, 6, 7, 8. And that means I have 8 out of 12. 8 out of 12 is really 2/3. And we will write that as a percent as well. So 66.7%. You can round that wherever you like. I'm really not going to be picky about that. Okay, probability of getting an odd number. Okay, here goes. Every integer is either even or odd. So I'm not even going to count this time yet. If I have 8 even numbers, then the rest of them are odd numbers. So I really didn't have to think too hard. I have 12 numbers on my spinner. 8 of them are even, so 4 of them must be odd. And you can verify it if you want to. You'd be like, there's 1, 2, 3, 4. There you go. That was it. 4 out of 12, that's 1/3, or 33.3%, which is kind of cool because this plus this equals 100%, because everything's either even or odd. Okay? Probability of getting a prime number, and now I have to identify which ones are prime. 2 is not prime, 7 is, that one's prime. That one is not prime, 2 times 4, that's 3 times 3. That one is not prime, that's, everything is even is not prime other than 2. So not prime, not prime, not prime. 5 times 7, so not prime. That's even, so not prime. Not prime, not prime, not prime. Well, there's just 1. There we go. 1 out of 12. That doesn't reduce, obviously, but what we will do is find out the percent. 1 out of 12, we'll multiply it by 100, and we get 8.3333333. I want to just call it 8.3%. That's going to be sufficient. All right, probability of getting a multiple of 5. So I want a number that divides by 5. Let me erase this right here. So 10 divides by 5, 20, 30, 35, 40, 45, and 50. All divide by 5. 1, 2, 3, 4, 5, 6, 7 out of 12. 7 out of 12 does not reduce, but we will do 7 out of 12 times 100, 58.3%. So 58.3% of the time, you would get a number, just a multiple of 5. Probability of getting a multiple of 10. Okay, we'll point to these instead of circling. Numbers that are divisible by 10 end in 0. So 10, 20, 30, 40, 50. There were 5 of them. So 5 out of 12. And 5 out of 12 is, let's not even multiply by 100. Let's just do what we need to do. Let's move the decimal 2 places. It's the same thing. So move the decimal 2 places. 41.6 repeating. I'll call it 41.7. So 41.7%. Okay, we're done, but I'm going to go back to the very beginning of the notes and start all over. I'm kidding. I'm going to write a better definition this time. So I said this was not the best definition. So now that we've talked about it, we're going to go back and fix our definition. So the number of desired outcomes possible. So this is the number of times that I could get what I want, divided by the number of items in the sample space. All right, that's a much better definition. Okay, number of items in the sample space. Like I have 6 things here. Well, the number of desired outcomes possible. Well, let's suppose I want an even number. There are 3 even numbers. Those are the number of things that I want divided by what I could get, which is the number of things in the sample space, which was 6. So 3 out of 6. So that is a much better definition. There you go.